Richard Feynman. The speed of light is not a speed that changes everything. Do you think yesterday ceased to exist? For Richard Feynman, time doesn't function like a line that erases itself. Science admits something that our intuition tries to deny at all costs. The speed of light is, in fact, a communication barrier between different slices of reality. Just as a city doesn't cease to exist simply because you left it, the moment you were born and the present moment are both stationary in the fabric of the cosmos. Prepare to understand why, for Feynman, the past is not a memory. It is a geographical coordinate where you are still living now. Richard Feynman didn't see time as we mere mortals do. For most of us, time is an executioner that devours what we've lived, leaving only blurred memories. But science, through the lens of Feynman and relativity, admits a much more solid and disturbing reality: the block universe. In this model, time doesn't pass. It simply is. The past isn't a ghostly mist that dissolved into thin air. It's a geographical coordinate. This means that the moment of your birth, yesterday, and the exact second you began reading this script are all stationed somewhere in the fabric of the cosmos. For Feynman, the past hasn't disappeared. It's you who have moved away from it. The geography of time. Where is yesterday? Imagine you are on a road connecting São Paulo to Rio de Janeiro. When you arrive in Rio, does São Paulo cease to exist? Obviously not. It continues to exist with its streets, people, and buildings, just at a different geographical coordinate from your current position. Feynman applied this same logic to time. Science acknowledges that time is the fourth dimension. Just as left and right or up and down are directions in space, before and after are directions in time. In the block universe, reality is like a film printed on a reel of film. If you look at a single frame, you see the now. But if you unroll the entire film on a table, you'll see that the beginning, middle, and end of the film exist simultaneously. The hero doesn't die and cease to exist on the film reel. He merely inhabits the previous frames. Almost no one talks about the implications of this, but Feynman understood. The past is a place we no longer know how to look, but it remains physically real, preserved in the eternal architecture of the universe. Yesterday is not a ghost. It's just a street where you're not walking at this very moment. The lantern of perception. Why do we feel the flow? If the past still exists as a place, why do we feel stuck in a present that always seems to be slipping away? Feynman suggested that this feeling of flux is a biological limitation, a kind of myopia of our senses, and not a property of fundamental physics. Our consciousness functions like a flashlight in a dark tunnel. As we walk through the tunnel, the light illuminates only a small circle ahead of us, what we call now. The fact that the flashlight is no longer illuminating the section of the tunnel we've already traveled doesn't mean that section has collapsed or disappeared. It remains there, solid and immutable. Physics admits that there is nothing in the fundamental equations of nature, from Newton to Feynman, that defines now as a special or unique moment. To an observer outside the universe, all slices of time would be visible at once, like a transparent block of ice with objects trapped inside. Feynman taught us that the past is simply the name we give to the coordinates that have been left behind in our four-dimensional trajectory. The universe line, the temporal worm. Almost no one stops to think about what happens to the atoms that formed you 10 years ago. Science acknowledges that your body is constantly renewing itself, but the exact configuration of those atoms at a past date has not been deleted from the universe's operating system. In Feynman physics, each particle describes a universe line. This line doesn't fade as the particle moves. It extends like a solid copper wire through the block of time. If you could see the universe in 4 dimensions, you wouldn't see a solid person, but a long temporal worm or tube that begins at birth and ends at death. Each segment of this tube is a version of you at a different moment. Your 5-year-old self didn't cease to exist to give way to your adult self. Both coexist at different points on this eternal string. Feynman physics posits that the past is the solid foundation that supports the structure of the present. Without the physical existence of the past, the block of time would crumble like a house of cards without a foundation. The speed of light, as a geographical barrier. Here's the crucial point Feynman was exploring. If light has a finite speed, it is in fact a measure of distance in time. When you look at the sun, you see it as it was 8 minutes ago. You are looking into the past. If the sun exploded now, you would continue to see it shining for 8 minutes. This proves that the sun's past is still there, sending information and interacting with its present. For light, time does not pass. Feynman used this logic to show that the separation between me here now and the sun there in the past is purely relative. The past is constantly leaking into our present through light. Almost no one talks about this, but the very existence of astronomy is conclusive proof that the past is a real place we can still observe. If the past had disappeared, the night sky would be an absolute void. There is a profound and transformative value in accepting the block universe. Richard Feynman, who experienced painful personal losses, such as that of his first wife, Arlene, found in physics a kind of solace that religion often failed to offer. If the past is a place, then the people we love who have passed away have not been annihilated by time. They are, in a very real way, inhabiting the temporal coordinates where they were always happy and alive. Science acknowledges that time is not a devourer of worlds, but a preserver of moments. Yesterday did not die. It became eternal. You are not an ephemeral being erased every second. You are a monumental sculpture carved into the fabric of eternity. In Richard Feynman's block universe, the past is the vault where your history is safely stored, protected by the most fundamental laws of physics against any attempt at oblivion. Yesterday is exactly where it has always been, on the map of the cosmos, waiting for the light of your understanding. Richard Feynman wasn't content with poetic metaphors about time. He sought raw mathematical proof, and he found it in a place where few would dare to look, in the bowels of matter. For Feynman, the antimatter, it wasn't just an exotic spacecraft fuel or a laboratory curiosity. It was the fingerprint left by the past on our present. Almost no one talks about it outside academic circles, but science admits, through Feynman's equations, that a positron, the antiparticle of the electron, can be perfectly described as an ordinary electron traveling backward in time. This is not a figure of speech. It is the mathematical interpretation that earned him the Nobel Prize and proves that the past has not disappeared. It is being revisited right now by trillions of particles. The mathematics of regression, the insight of Stueckelberg and Feynman. The journey to understand antimatter as a time traveler began when Feynman refined an idea proposed by Ernst Stueckelberg. He realized that the equations describing the motion of an electron in spacetime had a curious property: symmetry. If you take the equation for an electron, negative charge, moving forward in time, plus $, the mathematical result is absolutely identical to that of a particle with the opposite charge, positive, moving backward in time, $. Feynman had the courage to take this symmetry literally. He proposed that what we observe in our particle accelerators as a positron is nothing more than an electron that at some point in the future suffered a collision or interaction that bounced it back in the opposite direction of the time axis. Almost no one explains this with such clarity, but science admits, if the past were an absolute nothing, a non-existent void, the electron would have no ground to walk back on. The physical existence of antimatter is proof that yesterday is a solid and navigable territory for the basic constituents of reality. Feynman diagrams, temporal traffic maps. To visualize this madness, Feynman created his famous diagrams, which are now the standard language of particle physics. In these drawings, time flows from left to right, or bottom to top. A line representing an electron moves forward in time. Suddenly, it emits a photon, light, and the line bends, returning to the left. In this section, where the line points to the past, we label it as antimatter. Feynman showed us that we are not seeing two different particles, but the same particle at different points in its trajectory. It's like looking at a road and seeing one car going and another coming. Feynman physics suggests that, if you look closely, the car coming back is the same one that just passed you. But it found a way back in the future and is retracing its steps. This changes everything. If the particles that make up the universe can swim against the current of time, the concept of a vanished past, becomes physically impossible. The past is the reservoir from which these particles return. The single electron, hypothesis, a universe woven from a single thread. There was a moment when this idea reached its most radical peak. John Wheeler, Feynman's mentor, called him one night with a mind-blowing proposition. "Feynman, I know why all the electrons in the universe have the same charge and the same mass, because they are all the same electron." The idea was that a single electron would be frantically zigzagging between the past and the future, billions of trillions of times per second. When it travels to the future, we see it as matter. When it turns back to the past, we see it as antimatter. Although Feynman realized that this theory didn't explain everything, such as the asymmetry between matter and antimatter in the universe, he adopted the mathematics of this return journey as the basis of his quantum electrodynamics, QED. Science admits that this view works. It tells us that the universe is not a collection of static objects, but a tangle of trajectories that ignore our linear perception of before and after. The entropy barrier. Why don't we go back as well? If particles travel to the past, why can't you go back to last week and fix that mistake? Feynman explained that the difference between an electron and a human being is statistical complexity at the subatomic level. Time is a two-way street. But when you combine trillions of particles to form a person, you enter the realm of thermodynamics. It's like a deck of cards. It's easy to pick a single card and move it around. But if you throw the whole deck up in the air, the chance of all the cards falling in the perfect order of the past is almost zero. We are slaves to the direction of time, not because physics forbids us from going back, but because we are too large and too complex to coordinate all our particles in a simultaneous return. However, the fact that we cannot go back doesn't erase the road. Antimatter is there, being used in hospitals today, in PET scans, to prove that the road to yesterday is open and being traveled by subatomic passengers every second. The ultimate value of this topic is the deconstruction of temporal solitude. Almost no one talks about it, but if antimatter is matter traveling back in time, then the past is alive and pulsating within us. Your body interacts with these particles all the time. Feynman gave us proof that the universe has a physical memory. The past is not a record in a biological brain. It is a destination to which particles return to fulfill the laws of conservation of energy. Understanding antimatter from Feynman's perspective is understanding that goodbye is a limitation of our scale. At the level where reality is decided, the past and the future are in constant dialogue. Yesterday has not disappeared. It is the port from which positrons come, defying our logic and proving that time is much richer, deeper, and more circular than we ever dared to imagine. Richard Feynman was a master at understanding what the universe does with its secrets. In everyday life, we have the desperate feeling that things disappear. A burnt letter turns to ashes, a voice dissipates into thin air, a loved one departs, and silence takes over. But science admits a much deeper and more rigorous law, of which Feynman was one of the greatest defenders. Quantum information can never be destroyed. In the court of quantum physics, forgetting is an impossible crime. Almost no one talks about this with sufficient gravity, but for Feynman, the vacuum is not a graveyard of memories, but an indestructible archive. The past has not disappeared because the universe does not possess, in its source code, a delete key. Unitary, the guardian of cosmic memory. To understand why the past hasn't disappeared, we need to delve into the concept of unitarity. In quantum mechanics, this is the golden rule that underpins all of reality. It states that the sum of the probabilities of all possible outcomes must always equal 1 or 100%. If information about a particle's past state could simply vanish, the mathematics of physics would collapse. The universe would cease to be logical and become erratic. Feynman explained that nature is reversible at a fundamental level. If you burn a book, the information contained in the words seems to disappear to your limited human eyes. But if you could trace every molecule of smoke, every atom of ash, every photon of infrared light emitted by the heat of the flame, and every sound vibration of the crackling paper, you could, in theory, reconstruct the entire book. letter by letter. Science admits that the information has only become illegible or scattered, what we call increased entropy, but it is still there. For Feynman, the past is not a ghost that has disintegrated. It is a jigsaw puzzle whose pieces have been blown away by the wind, but the pieces continue to physically exist in the fabric of space-time. The vacuum as witness, the quantum record. Many people think of a vacuum as nothing, a void devoid of everything. Feynman helped prove that the vacuum is, in fact, a bubbling ocean of virtual activity. Through quantum electrodynamics, QED, he showed that empty space is constantly interacting with matter. When you move, when you speak, or when an astronomical event occurs, you are altering the state of the particles and fields that fill the vacuum. This interaction creates a kind of quantum echo. Almost no one stops to think that every interaction you've had in life has left a permanent mark on the electromagnetic and gravitational fields of the universe. Physics admits that these interactions are permanent at the information level. If the past had truly disappeared, the current state of the universe would have no mathematical cause. The fact that the present exists with the exact configurations it possesses is proof that the past is written in the structure of matter today. For Feynman, the past is the invisible foundation. You don't see the foundations of a building when you look at the 20th floor. But if the foundations weren't there, the building would fall into the void. The information paradox. Not even a black hole can erase yesterday. The idea that information never dies led physics to one of its greatest debates, involving giants like Stephen Hawking. The dilemma was, if something falls into a black hole, is the information destroyed? If the answer was yes, Feynman would be wrong, and physics would be broken. However, modern science, supported by Feynman's principles, tends to admit that not even the most voracious monsters of the cosmos can erase the past. They only encode it in an extremely complex way on their surface, like a hologram. This reinforces Feynman's view that reality is a self-contained system. If your past disappeared, the energy and information that composed it would have to go nowhere, which violates the most basic laws of nature. Therefore, your past is not a shadow. It is a structural part of the total energy of the universe. Almost no one talks about this because it is both frightening and wonderful. Every mistake you made, every tear, and every victory is encoded in the radiation and matter of the cosmos. The past is not something you leave behind. It is something you integrate, as it is interwoven into every atom of your present body. The true value of information conservation lies in the rediscovery of our own importance. Richard Feynman showed us that time is not a paper shredder, but an infinite collector. Science acknowledges that the trajectory of every particle is conserved. The past has not disappeared because the universe is a system that knows no forgetting. It is a book where the pages are never torn out. They are merely written with an ink that becomes invisible to those who do not have the right tools to read them. By accepting that the universe doesn't have a delete key, you change your relationship with existence. Every moment of your life gains infinite and eternal weight. You are not an ephemeral being walking towards the void. You are an indestructible sequence of information that the universe refuses to delete. As Feynman proved, yesterday is not silence. It is a symphony that continues to echo in the vacuum, ensuring that everything that has been lived continues to be, forever, an essential part of the whole. Science acknowledges that the past hasn't disappeared, but almost no one talks about it because the truth demands that we change our perspective on loss and longing. If yesterday still exists, if it's part of an eternal block, and if its information is indestructible, then nothing was in vain. Time is not your enemy. It is the museum where your life is being preserved atom by atom. Feynman gave us the formulas, but the conclusion is a philosophical gift. Nothing beautiful is lost, and nothing lived ceases to be real. The past has not disappeared. It is exactly where it has always been, at the heart of the universe's structure, waiting for you to understand that eternity is not what comes after, but what makes up each second of your now.